Nuclear fusion is the ultimate energy source in all of the universe. All lighted sources in space, like the stars and the sun, are lighted by fusion. But what is fusion? Nuclear fusion is the process of fusing two light nuclei to form a heavier nucleus which releases a large amount of energy. There are different types of fusion, but we're going to talk about the fusion between two hydrogen isotopes, deuterium and tritium. Let's start from the beginning. The sun is filled with hydrogen atoms, and those atoms undergo a process, which is what happens when the atom gets so hot that it gets rid of its electron, leaving only its nucleus. This means the sun is filled with nuclei and electrons zipping around, until deuterium is naturally formed and tritium through deuterium-deuterium reaction. Now, as I mentioned before, these nuclei need to fuse, and similar to magnets, two positive charges being pushed together would repel. When referring to atomic nuclei interactions, this is called the Coulomb barrier. The nuclei would need a lot of force to overcome this barrier. Maybe someplace has a lot of pressure or is hot. Coincidentally, we're on the sun, so that's no problem. Because of the high temperature and high pressure, these two nuclei have more kinetic energy, making them move faster, eventually getting close enough so strong interactions come in play. Strong interactions is what holds a nucleus together. Since it only has a positive charge, they would naturally repel, but this force acts like an elastic, surrounding it and forcing it together. So when these nuclei get close together, strong interactions allows them to fuse, becoming a heavy helium nucleus. Wait, heavy? Let's look at the overall equation. Deuterium and tritium fuse together, creating helium-4, a neutron, and some energy. It produces energy because the mass of deuterium and tritium combined is more than the mass of a helium and a neutron combined, providing energy according to E equals mc squared. This is why it's called heavy. Now, let's answer the most important question. Why should we care about nuclear fusion? This process releases an insane amount of energy. For example, 1 gram of deuterium and tritium isotopes can equal up to 12,000 kilos of coal energy. So this process can easily replace oil-fired, coal-fired, gas-fired, and even nuclear fission plants with a lot less environmental harm, as it's clean, does not produce greenhouse gases, and creates less radioactive waste. So, if it's all good, why aren't we doing it already? Well, first of all, we're on Earth, a place with low pressure unlike the sun, so we would need the temperature to be hotter than the sun, around 150 million degrees C. The problem is, we don't know how much money is going to go into solving these problems or building these machines or who's even going to be willing to pay that much. But we need to quickly decide whether the cost outweighs the pros of fusion. Because our Earth is dying and we need to solve this issue fast.